We have a very innovative exercise on an experiment done on the central limit theorem, and I'm going to take you to this website which shows this very conveniently in an easy to understand fashion. Right. So this is the website over here. You can find this link in the descriptions. Now the tool over here, it's in Java, which shows that whatever may be the distribution of the population, so I can change the distribution of the population over here. Let's say instead of a normal distribution, we have a very skewed distribution. Now this is definitely not a normal distribution over here, right? So this is the distribution of the hypothetical distribution of the population that we are going to extract a sample from. The mean for this population is 14.54, median is 14. What we can do is we can extract a sample of size 5 from it, right, and continue extracting multiple samples of say 5 of size 5, and we're going to plot the distribution of the means of such a sample. Let's say if I extract the first sample, this is the first sample being extracted, 1 2 3 4 5 extractions. So what we have over here, these are the values of the observations extracted randomly. So it's a simple random sample of 5 observations. These gives us the value. The blue pointer over here gives us the mean of these values over here. So if I again extract another sample, so let's say I click on animated once more, this is the second sample which has been extracted, right? This is the mean of the second sample, right? And the mean of the two samples over here is going to come over. We still don't have enough samples, so this is two samples that I've extracted over here. I'm to extract one more sample, 3 samples extracted, one more sample, let's say 4 samples. So I click it a number of times, and I've got multiple samples getting extracted over here, and we can see the distribution of these samples now. So I keep doing this, and what I start getting over here, this is the distribution of the sampling means now. Now what does the central limit theorem tell us? The central limit theorem tells us that irrespective of the shape of the population, right, if I continue to extract multiple samples, so in this case I've extracted 34 samples, the mean of those 34 samples will begin to follow a normal distribution, and we can see over here that a normal distribution is just about coming out now, right? So I'm up to 54 samples now. Let's click on 10,000 samples and see what happens. If I click on 10,000 samples, I see that the distribution of the means of those 10,000 samples is coming close to a normal distribution. If I click on this fit normal button, it shows how the expected distribution should have been, and the blue histogram shows us the actual distribution which is coming out, and it is showing an exact normal distribution. The mean of the sampling means, the central limit theorem tells us that the mean of all the samples that I extract will begin to approach the population mean. The population mean was 14.54, and the sample means are coming out to be 14.5, which is very close. Now instead of 10,000, I fit it up another notch. Let's push it to 100,000, right? And at 100,000 samples, it comes very close. So the population, the sampling mean is 15.54. It is coming very close to the population mean. And this shows that even if the distribution, and this is far from a normal distribution, the parent population over here, but the sampling means follows a proper normal distribution, right? And the standard deviation of this is 3.93, which is the standard error in our sampling mean, right? Let's try it once more time. I'm going to clear the lower tables. I'm going to create another distribution, and let this be the distribution. A very skewed distribution, as you can see. The mean for this distribution is 11.35. I extract a sample, a simple random sample again. That's the mean of this sample of size 5. The mean of these 5 observations is over here. And let's do it a couple of more times. So I'm clicking it right, a lot of many times. So let's see. And I am starting to get my distribution, as you can see. and this distribution should come around the mean that I expect it to be. I clicked something. Let me try it again. Let's go to straight away 10,000 10,000 samples extracted, and there we have it. Even though the population is very skewed, I see that the distribution is very close to a normal distribution. The mean that we are able to estimate from a sample of 10,000 samples is 11.32, whereas the actual is 11.35. It's very close. I go to 100,000, right, and I get it even close. So 11.37, just 0.02 off, right? And this is a tool on which you can test all of your hypotheses. Let's say we can try it again. Let's have something which is closer to a normal distribution. Let's remove these. I'm sorry. There we go. Right? Do it 10,000 times. You see, the population mean is 11.40. Sampling mean also 11.40, and very close to a normal distribution. Right? When it is not a normal distribution, let's say this is a very, very weird distribution, almost like a step function. The mean in this case is 14.44. Clear the lower three. Run it 10,000 times. Right, and I get mean is 14.45, and this follows a normal distribution. Isn't that great? Right, so this was a, a graphical representation of the central limit theorem. I hope you found it useful.